Okay, here are our two equations. We are on 7.1, problem number 5. And the directions say take this system of equations right here, this is number 5, and use elimination. As before, what we are doing is taking these two lines and we're figuring out if and where they cross each other. Now, since the directions say we have to use elimination, we probably should get these equations lined up. Do you see how this one isn't quite in the right order? So we'll go ahead and just recopy the first one. And then the second one, I'm going to move the 6y over. And now my equations are lined up. So as long as they're lined up, now I can use my elimination process. So you probably have some thoughts about that. I think I'll multiply the top one by -2. And remember, that does mean all the way across. So we're going to multiply everything on top by -2. Now the bottom equation isn't going to change. I just multiplied the top one by -2. Now when I do that, what happens? Well, it looks like when I add them together, doesn't everything cancel out? Which leaves me on this side with a 0, because everything canceled, and on this side with a 0. That is a true statement. So what does that mean? That means that these two lines are actually the same line. So there are infinitely many solutions, and what you write down is these are the same line. Now that is not what happened on problem number 6. On problem number 6, which we did yesterday, the equation came out to be something like 0 equals 5 or something. I don't remember what it came out to be. But it wasn't 0 equals 0. It was 0 equals a different number. And that means they're parallel. That means there's no solution. This is different than that. 0 equals 0 is true. And so that means the two lines are the same. They intersect everywhere. And so this is what you write down as the answer. All right, good job. Now, before we move on to the next step, which is very new, I am going to do a quick review of what we've done so far. And you are remembering, of course, that we can't do any quizzes until we get back. So these videos of review material will always be available to you, so you can come back and look at them at any time. So let's take a look at this equation, or system of equations, I mean. This is not in your notes. This is a separate problem. So why don't you pause the video, get out a sheet of paper, and do this right along with me, and then keep track of it. Keep it. These directions, I'm going to say, are substitution. So we're going to solve this system using substitution. Now remember, what that means is we get one of the variables by itself. So you can either get this one by itself or this one by itself. It's whichever one you want. I'm just going to go ahead and get this by itself because it's on top. It does not matter one bit. So x equals 7 minus 3y. I'm going to subtract the 7y over to the other side. So now I have x equals. Then I can take this guy right here and plug him in right here, because this is what x equals, so I can put him in, substitute him in place of x. So 2 times 7 minus 3y plus y equals 4. 14 minus 6y, I'm doing my distributive property, plus y equals 4. The beauty of this is, if I'm going too fast, pause me. That's the nice part about video. So then 14 minus, I'm going to collect these like terms, 5y equals 4. I'm going to subtract 14 know how, if you can see that or not down there. Yep. So that leaves me with negative 5y equal to negative 10. So y equals 2. Now we remember that when we are solving a system, it isn't enough to have y. If y is 2, we still need to find x. So we can come back up here, for example, put 2 in for y. If you put 2 in for y, that's 7 minus 3 times 2. So x is 1. And the answer to the problem is 1, 2. So I did that problem using substitution. Remember, we have to be able to do both methods. All right, so that one's substitution. Now, let's practice one with elimination. So again, this is just a random practice problem I made up. And we're going to do elimination on this one. So this one is elimination. The directions say use elimination to solve. So actually, everything's lined up pretty nicely. So, I don't know. You have a choice. Maybe we'll multiply the top one by 2. And remember, and I know I've already said this, but when you do that, you must multiply the entire equation, every number in it. So that gives me negative 4x plus 2y equals 14. Negative 4x plus 2y equals 14. This equation I'm not going to change. And now when I add them together, it's going to do exactly what I wanted. It's going to cancel out the x's. The problem is, what do you notice? It also cancels out the y's. So everything over here is gone, and this is 17. Now, does 0 ever equal 17? No. So do you remember what that means? That means these lines are parallel. They do not intersect. There is no intersection. So you can either write empty set, indicating there's no solution. You can say they are parallel lines, which is actually a great way to say it. But empty set is fine too. There's no solution. These are parallel lines. They do not intersect. If you drew them, if you graphed them, they would look like this. They are parallel to each other. All right. Let's do one more review, and then we're going to start something brand new and exciting and fun. All right, so here we go. X plus 5y equals 10. Negative 2x minus 10y equals negative 20. Again, I hope that you are doing these on a separate sheet of paper so that you can come back to them later and review them when it comes time for us to have a quiz over all of this, when we finally get back together. I miss you guys. Okay. Directions say substitution. Remember, on your quiz, you will be told whether to use substitution or elimination. So this time it's substitution. So here we go. For substituting, this is the only variable that's by itself right here. So I'm going to go ahead and get that one by itself. So x equals 10 minus 5y. I'm just going to subtract 5y over to the other side. Now, here is x. This is what x equals. So now I'm going to plug it in. So negative 2 times 10 minus 5y minus 10y equals negative 20. I just took that right there and substitute it in right here. Now I got to clean all this up. So negative 20 plus 10y minus 10y equals negative 20. Oh my. Are you noticing what I'm noticing? What happens right here? These are gone. So what does this equation now say? Negative 20 equals negative 20. Is that true? Kids, that is absolutely true. That is always true. So what does it mean when we get a statement like 0 equals 0, or negative 20 equals negative 20, or anything else equals itself? What does that tell you about these two lines? Yep, they are the same line. And that's what you write down as your answer. They are the same line. They have infinitely many points of intersection, because if you drew one of them, the other one would be right on top of it, and they would intersect in bazillions of points. All righty, good work. Now we're going to talk a little bit about matrices. So if you turn to the next page of your notes, 7.2, actually the page is actually labeled 44, but it's 7.2 vocabulary. And again, if you're having a hard time keeping track of this, just pause the video, find what you need so that you can pick up with us and start in. So we got some vocabulary to talk about. We're going to talk about matrices. I really don't know what you have done, if anything, with matrices. So I'm going to kind of assume that you've never done anything with them. So if this is review for you, great. If it's brand new, then you'll just learn as we go. Okay, so we're going to start with figuring out or learning what exactly is a matrix. What is the definition of a matrix? Well, if you look at your note sheet, down there, problem number 1, where it says let A equal and B equal and C equal, you see boxes of numbers, basically. Those are matrices. So the things there that you see right here, these are matrices. These are examples of matrices. Now, what is the definition? Please don't say it's a box of numbers. That's how you can think about it yourself. But a matrix is a rectangular array of numbers. Uh-oh. My board's falling down. Of numbers arranged in rows and columns. So I think that probably makes sense to you when you look at it. And I'm sorry, I'm not writing very straight. This isn't the ideal situation. I may be able to figure out something better as we get into this, but right now this is what we got going. So I'm sorry it's a little crooked. But that's your definition of a matrix. So I'm going to just give you an example of a matrix. I'm just going to call this one, I'll call this matrix F. There is matrix F. Now we're going to talk about the other vocabulary words here. So B says, what are the dimensions? Sometimes called the order of the matrix. The dimensions of the matrix are the rows by the columns. Now, when I say this, I mean it's the number of rows by the number of columns, and that looks like a times sign, but just like when you measure the dimensions of a room, you say it's 20 by 30, that's a by. We say that by by. So rows by columns. So this one, it has 3 rows and 2 columns. Now, to remember that, I want you to think about the rows of a bleacher. The rows of the bleachers go this way. They're horizontal. So this guy has 1, 2, 3 rows. Columns are like the columns of the White House. 1, 2. So rows go sideways, columns go up and down. And if you ever forget what order they go in when you do this rows by columns, remember, we're a Roman Catholic school. RC. Rows, columns. That's how we remember the order of the matrix, or the dimensions of the matrix. So this guy is a 3 by 2 matrix. Now, the next definition on your sheet is for a square matrix. A square matrix would be a matrix that had the same number of rows as columns. So, an example of a square matrix might be something that looked like this. That is a square matrix because it has 2 rows and 2 columns. Now, square matrices are special. In matrix land, we like square matrices. But again, the definition is very simple. You have 2 rows and 2 columns, or you have 3 rows and 3 columns. You have the same number of rows as columns. Now, the next definition, so by the way, this is not square because it does not have the same number of rows as columns. Entry or element. The numbers within the matrix are called the entries or the elements. So let's write down on our notes the definition of entry is the numbers within the matrix. So this is an entry, this is an entry, this is an entry, this is an entry, this one, and this one. So this particular matrix has 6 entries or 6 elements. This one would only have 4 entries or 4 elements. The entries or the elements of a matrix are simply the numbers within the matrix. Now, this is a notational thing that you need to pay attention to. If I want to talk about, let's say, this number right here, that entry in the matrix, he is a member of matrix F, and I use capital letters for my matrices. If I wanted to talk to you about him, which I guess I am sort of remotely here, if I wanted to talk to you about him, I would use a lowercase f to indicate he was coming out of matrix F, and then I would put a little subscript down here, 21. Now that is not a 21, that is a 21, which indicates go to matrix F, look in the second row and the first column. So if I go to matrix F, rows go this way. So the second row is right here, and the first column is right here. That would be the number 3. If I want to talk about any entry in this matrix, I'm going to use a lowercase f, and then I'm going to put a subscript on it to indicate its position in the matrix. So let's have you try this one. What about this? What would the entry in matrix F in the 1, 2 spot? What does that mean? That means look in the first row, second column. So the entry in the first row, remember rows go sideways, and the second column would be right here. So that entry is 2. Remember, every time we talk about matrices and we are speaking about their size or their location, it's always rows and then columns, always. So this is a row number and that's a column number. Okay. Now I'm going to keep my matrix F there. I got to erase this right here. Okay. And I am going to take matrix F and I'm going to put a big old 2 out in front of it. Now, do you have any idea what you might do with that big old 2 out there? I hope you kind of have a guess. You take every number in matrix F and you multiply it by 2. So that's 2, 4, 6, 8, 10, 12. And that is 2F. The number 2 has a special name. It is called a scalar. That is the next vocabulary word on your paper. A scalar is nothing more than a real number. It can act as a coefficient, it can act as a magnitude, it can act as a lot of things. So just define scalar as a real number. If you put a scalar out in front of the matrix, all you're doing is multiplying by that number. And finally, your last definition, equal matrices. Equal matrices. What it means to be equal matrices, I'm going to go ahead and erase this, is that they have the same entries in the same spots. So we have to be careful when we define equal matrices. So let me write it down. Equal matrices. Same entries in same spots. And same size. So obviously, if two matrices are going to be equal, they have to be the same size. And then they have to have the same entries in the same spots. Now, the reason it's important to include this, sometimes we just say, oh, they have the same entries. Well, you got to be careful because it would be possible to have this matrix. Is that still showing up? Yeah. And this matrix, let me do it up here. Let me do it up here. So you could have this matrix and this matrix. And they have the same entries. Oh, shoot. They have the same entries, don't they? But the entries are not in the same spots. So these are not equal. These two matrices would not be equal. To be equal, you have to have exactly the same entries in exactly the same spots. So these are not equal. This is your definition of equal matrices. Same entries in same spots and the same size. All right, so that's your vocabulary. If you missed any of that because of my tumbling down board or anything else, if you missed any of that, then please just rewind, go back, and watch it again. It's all there for you, and you are responsible for knowing the definition, so be sure that you do. Okay, so now we're going to do problems using the ideas that we have come up with here. So A, problem A, I'm on 1A. It says, what are the dimensions of matrix A? Now, matrix A is this. And I want to know, what are the dimensions of that matrix? Well, remember what dimensions are. Dimensions are rows by columns. Rows go across. Rows of a bleacher, sideways, go across. So the rows of this matrix, how many are there? 2. How many columns are there? Columns go up and down like the White House. How many columns are there? 2. So the dimensions of this matrix, 2 by 2. B, on the other hand, looks like this. What are the dimensions of B? Well, how many rows? Rows go across, so there's 2 of them. How many columns? Columns go up and down. There's 3 of them. Rows, columns. Okay. Now, B. Notice the little letters. The little letters in B, problem B, would indicate that we are looking for entries. So, first one says A sub 2, 1. Now, little a's come out of big A, and the 2, 1 means second row, first column. So we're in the second row here, and the first column. So that is 3. You see that? Second row, 1, 2, first column, right there. Then B sub 1, 2 would mean, go to matrix B, first row, second column. So that would be a 0. And then matrix C, I don't have that on here, so I'm going to squeeze it in down here. Matrix C is negative 1, 1, 4, 0. This is matrix C. And I want to find the entry in the 3, 1 spot. Now, first of all, I know I'm looking at matrix C because that's a little c. This means find the third row, first column. Whoa, 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 wait a minute. What are you noticing? Matrix C does not have a third row. 1, 2, the third row would be down here. Doesn't have it. So that is no answer. Mrs. Ford's getting a little wild and wacky, a little tricky there. No answer. Okay? All right, so that takes care of B. All right, C. Now we're going to add. Okay, so we're going to add, we don't need these circles anymore. We're going to add matrix A and matrix B. Now, guys, you can't do that. Do you have any idea why it is not possible to add A and B? Are you thinking? Are you saying it out loud? Are you guessing? What do you think? You can't add A and B because they are not the same size. When you add these matrices together, you're going to add their corresponding entries. In other words, you're going to add this number to this number. Well, the problem is you got too many numbers in matrix B that don't have matches in A, so they're not addable. The only way that you can add matrices, make a note of this, the only way that you can add matrices is if they have the same dimension. They must have the same dimension or they aren't addable. So A and B can't be added. All right, so then D, that was C. Problem C, can't do it. D says let's add A and C. Now, are these going to be addable? I believe they are, because what are the dimensions of this matrix? 2 by 2, 2 rows, 2 columns. What are the dimensions of this one? 2 rows, 2 columns. So guess what? They can be added, and they will give me another matrix the same size. So here we go. We're going to add these. So we're going to add the entries that are in corresponding spots. So we're going to add right here. We're going to add these two together. So that will give me 0. Now I'll add these two. You see what I'm doing here? 2 and 1. I'm going to add these, 7. I'm going to add these, -4. Adding matrices is incredibly simple. You just do it entry by entry. The only thing you have to be careful of is they have to have the same dimension. If they're not the same size, they aren't going to be able to be added. If they are the same size, then go ahead and add them. That is pretty darned easy. Now, we already talked about the next problem. The next one, what is it? The next one is E. We're ready for E now. And E says, take 2 times A. Well, this is A, so I'm going to take 2 times it. This is problem E, 2 times it. So what's 2 times the matrix going to be? Well, remember, we already talked about this. You just take 2 times everything. So it's going to be 2, 4, 6, -8. That's it, just 2 times every single number. It's like the distributive property. You're just distributing the 2. And oh, by the way, a bit of review, 2 is called a scalar. 2 is called a scalar. Okay, now we're going to do 2C, I'm on problem F, 2C minus A. Now, before I get too far into this, first, please make sure I copied it all right. You guys aren't here to correct me. Hope I copied everything right. This is just like addition. Subtraction has the same rules as addition. You cannot subtract if they're not the same size. Well, we're in luck, aren't we? This is a 2 by 2, and that's a 2 by 2. So we're going to be able to subtract. But before we subtract, we're going to have to do something else. We're going to have to do our scalar multiplication. So this one will be -2, 2, 8, 0. So -2, 2, 8, 0. And then minus 1, 2, 3, -4. Now, when we subtract, we do it just like when we add. So we're going to take the first numbers in each matrix, only this time we're going to subtract them. So -2 minus 1. -2 minus 1 is -3. Then move over here, 2 minus 2. Eight minus 3, 0 minus -4. So again, when we subtract matrices, once we got our scalar distributed through, when we subtract, we do it by corresponding entries. So this guy and this guy are corresponding entries. They're in the same spot. So we subtract them. And then same thing here, here, and here. And that's your answer. All right, that's F. Now we're ready for G. G says, I'm going to do B minus 2A. Okay, now B minus 2A is what? 203, negative 114, minus 1, 2, 3, negative 4. And I want 2 of those. So it's B minus 2 A's. Now, I actually wrote this down, but I hope you were thinking, as I was writing it down, I hope you were thinking, oh, wait a minute, this isn't going to work. Why isn't it going to work? This matrix has 2 rows and 3 columns. This matrix, I know I haven't distributed yet, but it's not going to change the size. This matrix has 2 rows and 2 columns. Can those be subtracted? No. They cannot be subtracted. They cannot be added because adding and subtracting require you to have exactly the same size of matrix. Okay. All right, so now we're moving on to the next page, and we're going to do a little bit of multiplication. So here we go. The multiplication is a little bit harder than addition and subtraction. But once you get the hang of it, it's pretty fun. But we just need to get the hang of it first. So here we go. First problem, I turn the page, so now I'm on problem number 2, where it says let, got all these matrices here. And I'm going to do A times F. Now, A, oh wait, I'm using A from the other page. So A is 1, 2, 3, negative 4. And I'm going to times that by F, which is negative 1, 5, 3, and 0. So the A is from the previous page, then the F is up here, and we're going to multiply these 2 together. Now, I need you to pay real close attention, and you may need to replay this a couple of times till you get the hang of it. Once you get the hang of it, it's easy, but it is a little bit strange getting started. So here are the steps. The first thing you have to do is check the dimensions of each matrix. So this guy is 2 by 2. And again, 2 rows, 2 columns. This guy is 2 by 2, 2 rows and 2 columns. Now, to multiply, please listen carefully, make a note of this. To multiply, the inside 2 must match. It does not matter what these are. The inside 2 must match. They do not have to be square matrices. They do not even have to be the same dimensions, but these have to be the same number. So you could have a 5 by 8 and an 8 by 2, and that would be absolutely fine to multiply. Obviously, you can't add those, but those would be fine to multiply. Okay? What's the rule for multiplication? The inside 2 must match. When you write the dimensions, rows by columns, the columns of the first must match the rows of the second. These do. So, what does that mean? Well, that means that my answer will have these dimensions. These give me the dimensions of the answer. So my answer is going to be another 2 by 2. Here they are, 4 spots that have to be filled in. Now, if it helps you keep track of what's going on, you can put little subscripts under here. So like you might put a 1, 1 under here, because that represents first row, first column. And then this would be 1, 2, first row, second column. 2, 1, and 2, 2. Now that helps some people, it confuses other people. So do it or don't do it, I don't care. But it does help you, some of us, it does help some of us keep track of exactly what we are multiplying. Okay, so how do we start this thing? We have figured out that we can multiply because these two match. We have figured out then that our answer is the outside dimension, so it's another 2 by 2, and we've set it up. Now I'm going to find that number right there. I'm going to find this number right here. Right there, that number. That number is in the first row, first column. So I am going to multiply the numbers in the first row and first column. So the first row and the first column. Row of the first, column of the second. What does that look like? We can do this different ways. I'm going to go ahead and write down the 1 and the 2. There they are, the first numbers. 1 and 2, that's my row right there. And then next to those, I'm going to put the column numbers. So a -1 and a 5. So I wrote down the 1 and the 2, and then I wrote down next to those the -1 and the 5. It's -1 and 3. So let me start over. So I wrote down my 1 and 2, and then I wrote down my -1 and 3. This row and this column. Okay? Now, I'm going to multiply these together. I'm going to multiply those together, and then I'm going to add them up. So I multiply these, and add them. So that number that goes in this spot right here is a 5. -1 plus 6. Now, I told you it's a little confusing at first. Do not panic. Hang on. Remember, you can replay me as many times as you want. All right, let's try the next spot. So now we're going for this spot right here, okay? Now, what spot is that? That's in the first row, but now it's in the second column. So now I've got the first row and the second column. First row, second column. First row, second column. First row, second column. So I'm going to take that first row again. I'm going to do it over here. That first row is 1, 2. And my first column is 5, 0. So I write down the numbers in the first row. And then right next to them, I write down the numbers in the second column, 5, 0. So 1, 2, 5, 0. Now I multiply each pair and add them together. So I have a 5 and a 0. So this number is also a 5. That's coincidence. Please don't think that happens all the time. It doesn't. It's just coincidence. I got the same number. Okay. Now what are we ready for? Now we're ready for this spot right here. Now where is that spot? Well, it is in the second row, and first column. So it is the second row and the first column. Notice I'm always using the rows of the first matrix and the columns of the second matrix. So row 2, column 1. So I'll write down my 3 and -4, and then I'll write down my -1 and 3. Now remember what we do? We multiply these, and we add them together. So what goes in that spot? Y, -15. Now, what's next? We have one more number to find. And how are we going to find it? Have you gotten the hang of it? Are you starting to get this a little bit? We need, where are we? That number right there is in row 2, column 2. So we are going to multiply row 2 times column 2. Remember, it's rows of the first, columns of the second. So we have our 3 and our -4, and we're going to multiply it times 5 and 0. So what do we end up with? I got 15. Did you get 15? It's 15 plus 0. So that, my friends, is the answer to the question. Wow, that's a lot. So that's A times F. Now, if you look at the next problem, it says F times A. Now, you might be thinking, well, wait, won't that be the same thing? Well, with regular numbers, it sure would be, but I don't know what's going to happen since these are matrices, so we're just going to have to work it out and see. So let's make sure I copied them right. That's F, and then A, remember, is on the other side. There it is. Okay, so now we're going to multiply F times A. So I'm going to go back through all the steps to remind you that when we are multiplying, we have to make sure that our dimensions are appropriate. They don't have to be the same. We remember what has to happen. This matrix is 2 by 2, 2 rows, 2 columns. This matrix, 2 rows, 2 columns. But I don't care that they match exactly. All I care about is that these two match. And they do. That means that these matrices can be multiplied. Furthermore, this will give me the dimension of the answers. So the insides match and the outsides tell you the size of your answer. It's another 2 by 2. Okay? All right, let's start finding them. Now again, this is completely up to you. But sometimes it helps to stop and think about what these positions represent. So this guy is row 1, column 1, row 1, column 2, row 2, column 1, row 2, column 2. Now again, do not write that down if that's going to confuse you, okay? Do not write it down if it's going to confuse you, but sometimes it does help. So, regardless, you got to find this guy right here. He is in the first row, first column. So we are going to multiply the numbers in the first row, -1 and 5, times the numbers in the third column, 1 and 3. So again, I'm writing down my first row, and then right next to those numbers, I'm writing down the column numbers, and then I'm going to multiply the pairs and add them together. Well, I got a 14. Now I erased it, but look at your sheet. Is that the same thing we got when we did AF? This is FA? No. Matrix multiplication is not commutative. Order matters. So we're going to get an entirely different matrix multiplying in this order. All right, I'm going to pause for just a moment, and I would like you to see if you can fill in this next number right here. See if you can fill that in without my guidance. You're going to be multiplying the first row and the second column. So see if you can do that while I'm erasing and getting things set up here. Hopefully you are multiplying -1, 5. That's your first row. So there's my -1 and my 5. And you're multiplying that times 2 and -4. So hopefully when you multiply and add, you got negative 22. Okay, here we go. Now we're ready for that bottom row. And when we're doing the bottom row, of course, now we have to use row 2. So we're going to use this row. So we're going to use 3 and 0 now as our numbers. And for this first one, we're going to use the first column. So we'll be using 1 and 3. So we're going to multiply 3 times 1 and 0 times 3 and add them up. Did you get 3? I hope so. And then finally, we'll fill in that very last one. So we need our second row. So again, we need the 3 and the 0. But this time, we need our second column, which is 2 and negative 4. So 3 times 2 and 0 times negative 4. I got 6 for that. How about you? Is that what you got? Hopefully. Good, good, good. All right. We're going to do one more. Time flies when you're having fun. We're going to look at problem C that says we're going to multiply D times E. We're going to multiply D times E. Now, before I get it all copied down, what are the dimensions of D? D, look at matrix D up there at the top. D has 2 rows and 2 columns. What are the dimensions of E? E has 3 rows and 3 columns. The matrices are there at the top of the page. So D has 2 rows and 2 columns. E has 3 rows and 3 columns. Now, they're both nice little square matrices, and that's awesome. But are they multipliable? No, my friends, they aren't multipliable, because what is the rule for multiplication? The inside dimensions must match. They don't match. And because they don't match, we can't multiply. And the answer to question C, the one that says what's D times E, the answer is can't do it. So you can write empty set, you can write can't do it, you can write inside dimensions don't match, whatever you want to write that indicates the problem is not doable. On test day, if you just leave it blank, I'm not going to give you credit. But if you say empty set, can't do, dimensions don't match, whatever it is, inside dimensions don't match, all that would be perfectly fine. These 2 matrices cannot be multiplied. So we will pick up there next time. I want to remind those of you who have not yet taken the probability test that you need to continue reviewing on your own, as you will be taking that upon our return to school. Okay, everybody, have a great day. Thanks for checking in. Bye.